right, I'm just gonna wait. Okay, good. YouTube is streaming this now. All right, good. Sometimes I have a problem with this whole YouTube streaming thing. Hello, my intrepid scholars. How you doing? Your humble host, Mr. Solt, that is I. I'm going to provide some little supplemental instruction here. Right? We've already gone over this stuff in class, but sometimes in class, while you're attending class, there can be distractions. Right? Maybe it just wasn't a good time. Or maybe what happens in class happens really fast and you didn't catch something. So I'm just going to provide a few videos for some of these assignments to provide just a little supplemental instruction so you have a little bit of basis. You can go back in time and get a little bit of this stuff. All right. So this is actually, let's see, this is number 12, right? This is assignment number 12, I believe. Unit 2, lesson 1, two variable categorical data. All right. What is categorical data? Categorical data is qualitative data. Categorical data is qualitative data. It's the kind of data that involves variables that cannot be measured numerically. For instance, like gender, male or female, that's not a category or a quality that can be measured with a number. Okay, so that's going to be categorical. It's going to be qualitative. Your favorite sport, right? If you like perhaps the Buffalo Bills or any other sports team, you can't. The Bills is not a numerical data, right? It's a categorical kind of data. Your favorite color, the kinds of different shapes, these kinds of things. We would use words to express these things, and we wouldn't measure things in terms of color generally or shapes generally, right? So this is the idea. There is this idea that some kinds of data are categorical. They are qualitative. They cannot be measured numerically. And then there's also what we have here is quantitative data. Quantitative data, as you might guess, it involves quantities, right? Quantitative data involves quantities, and it is the kind of variables that can be measured numerically, right? If you can measure something numerically, that's going to be quantitative data. Things like height, the number of cars in the street, anything you can count, anything you can measure numerically is going to be qualitative data. All right. And two-way table. We're going to see what a two-way table today, what a two-way table is today in this video. And it's a table that shows frequencies for two corresponding sets of categorical data, right? So if we have two corresponding sets of data, like for instance in this lesson we're going to look at a survey where high school students were asked, what would be your preferred superpower? If you could pick a superpower, what would you pick? And these things were measured, these things were recorded by gender, right? So males and females both recorded their gender on this sheet for the recording of this data. And that gives us two different variables to look at, right? That gives us what gender the respondent is and also what their preferred superpower is. We'll show you how that will work. And then there's this term we're going to use in this lesson called frequency. Frequency is the number of times a value occurs in the data set. So when we talk about a two-way frequency table, right, it's going to be a table that gives frequency or counts numbers of different instances of categorical data, right? And let's see. I'll explain this more, but we're going to look at marginal frequencies, which are entries in the total row or total column of a two-way frequency table. And there are going to be entries in the body of the table are called joint frequencies. I'll show you that later. That'll make more sense when you actually see the table, okay? So example one we have here. High school students in the United States were invited to complete an online survey in 2010. Part of the survey included questions about superhero powers. More than 1,000 students responded to the survey that included a question about a student's most favorite superhero power. 450 of the completed surveys were randomly selected. A rather confusing breakdown of this data by gender was compiled from the 450 surveys. So keep in mind, this next list that we have highlighted here, if this is confusing, that's kind of the point, is that if we just list data like this in a line, it's not very efficient. This two-way data table, two-way frequency table is a much more efficient way of displaying the data. So I'm going to read these lines, and if they seem confusing at first, then that's kind of the idea. We're going to show you this is probably not the best way to organize data. And remember, statistics is all about the organization and analysis of data. We're going to show you maybe how maybe data shouldn't be organized, and maybe how it could be organized, right? So number one, 100 students indicated that their favorite power was to fly. 49 of those students were females. 131 students selected the power to freeze time as their favorite power. 71 of those students were males. 75 students selected invisibility as their favorite power. 48 of those students were females. 26 students indicated super strength as their favorite power. 25 of those students were males. And 118 students indicated telepathy as their favorite power. 70 of those students were females. So the first question asks, what was the most popular superpower? And again, like there's going to be notes on this page where the answers are already here because we already did this in class. In fact, you have a copy of this very document that I'm looking at. So, I'm not giving anything away here. This is all stuff you have access to, maybe didn't know you had access to, okay? What's the most popular superpower? Well, it's to freeze time, right? Because if we look at all these different numbers here, we see 131 was the biggest number of students that selected the power. And so yeah, to freeze time was most popular with 131 students. What was the least popular? Well, we look at this. Super strength, only 26 students. 26 students is the smallest number out of all these other respondents. Super strength was the least popular with 26 students. Why would the survey include gender? Well, why might you be interested in asking people what their gender is? Because maybe gender gives what the respondents say to us as to what their gender is, might give us some insight as to the similarities and differences between the genders as to their preference of superhero power, right? It would be kind of interesting if there was a power out there that, males were more likely to prefer over females, or another superpower that maybe females are more likely to prefer over males. That gives us some interesting ability to analyze this and ask other questions like, why is that? And then maybe we can dig further into the data and find out why that might be. Apologize for the whole, binary assumption there. That's just, for the purposes of a math problem. My apologies. Anyway, do you think that gender plays a role in superhero power preference? Well, at least in this scenario, it did provide a little bit of a preference, right? So we had the situation here where 26 students indicated super strength as their favorite superpower, and 25 of those students were males. So isn't that interesting? Not only was super strength the least popular of all the powers, but 25 of 26 students that chose that were males. So what is it about these 25 young men that makes them want superpowers, and what's going on with that one female that wanted super strength? What is that dynamic that made this kind of come out this way? It's kind of interesting little wrinkle in the data that we might want to learn more about. Number 5 is how many more males than females indicated their favorite power was to fly? Well, 100 students indicated their favorite power was to fly, and 49 of those students were females. We got that from above, right? Well, if we know 100 students indicated their favorite power was to fly, and 49 was females, and we assume the whole gender binary thing, then 100 minus 49 equals 51, which means if 49 of those people, the 100 are females, then we could, again, with the whole gender binary thing, assume that 51, then the remaining are male respondents, okay? And then there's 51 male respondents, 49 female respondents. The difference between 51 and 49 is 2, okay? So number 6 is how do you think? Oh, and I might be moving kind of fast through these. And with a video, I feel like that's okay. Number one, you can always slow down a video, right? You can go into YouTube and the quality and the settings and slow me down to 50% speed or 75% speed. Another thing too is that hopefully you've already attended class and got all this in class. And thirdly, you can pause me, right? Anytime you need me to pause me to write something down or complete your side of the work, you go ahead and do that, all right? Or alternatively, too, you can fast forward me. If you've already got everything you need here, you can just fast forward to the part you need. All right, and you can kind of use my screen as a reference guide of what you need. And I just realized that I could probably zoom in a little bit for you without, right? Yeah, I could zoom in a bit. I think that'll be good. Yeah, all right. That's better, right? That's a little bit more convenient. All right, how do you think that 450 surveys used in example 1 might have been selected? You can assume that there were 1,000 surveys to select from. Well, we found out if you read that in example 1, it said that 450 of the selected surveys were randomly selected. Now, it doesn't tell us how they were randomly selected, and we're going to go into later in this class. There's a half dozen different sampling techniques. There's stratified sampling, cluster sampling, true random sampling, convenience sampling, all this stuff. So we're going to get into that. We don't need to bother with it now. The methodology here, we could say, is randomly selected. All right, a two-way table. So here it is. Here's this two-way table we've been talking so much about. All right, this is a two-way table, and it's not doesn't it's it, nor, in each one of these little boxes here there would be usually a number, a frequency, right? And this we're counting. What we're doing here is we're taking these categories and we're putting them in a table, and we're counting how many times to fly, the category to fly shows up, and that gives us a number, right? How many females chose to fly? That gives us a number, and then we can compare that to how many males chose to fly, right? And this table helps us organize our frequencies. A two-way frequency table can be used to organize the categorical data as shown below. The letters below represent the frequency counts of the cells of the table. And each one of these little inner boxes here, right? These inner boxes is called a cell, a spreadsheet language. And we'll get more into it in a second. But everything here in white, A through E, and then G through K, these are all joint frequency boxes, okay? And why are they called joint frequency boxes? It's because they're joining two categories, okay? So to fly, how many females chose to fly in number A is joining two categories together. This is a joint frequency. How many males wanted invisibility, right? I. How many males, horizontal row, wanted invisibility, column. I would be the number of males that wanted invisibility would go in here. And this is why this is a joint frequency, because you're joining two categories together in terms of their frequency. And then, of course, all of this dark shaded gray stuff is the marginal frequency boxes or cells. All right, all our marginal frequencies go in these gray shaded boxes. And why are they marginal? It's because they're on the margin, right? And so here M is going to be the total number of respondents that wanted to fly, right? And M will be the total number of respondents that wanted to fly. Over here in P, we're going to get the total number of the respondents that wanted super strength, okay? See how that kind of works, the total of super strength there for P, and so on. So, as I've already said, the shaded cells there are called marginal frequencies because they are located around the margins of the table and represent the totals of the rows or columns of the table. The non-shaded cells within the table are called joint frequencies. Each joint cell is a frequency count of the responses from the two categorical variables located by the intersection of a row and a column. All right. So, actually, this table's already been changed a little bit, right? We've already done some of the work here, and because we've already answered some of these. So, number 7 says, describe the data that would be counted in cell A. And I think I'm going to zoom back out a little bit because I want more of the page to be shown to you at once. All right, there. So maybe I zoomed out too much. All right, that's more like it. All right, describe the data that would be counted in cell A. Actually, I already talked about that, didn't I? Right? It's the number of females that selected to fly, right? Because there's A right there. It's the number of females that chose to fly as their preferred superpower. Describe all the data that would be counted in cell J. Well, where's J? Where's J? Oh, right there it is. Right there's J. So now I have to look at the row. That's males. The row is males. The column is super strength. So J describes all the males that chose super strength as their superpower. Looking at question number 9. Describe the data that would be counted in cell L? I find cell L over here. Oop, right there, there's cell L. So cell L is going to be a marginal frequency, right? Marginal frequency because on the margin, and it's going to be the total number of males that responded, right? It's going to be the total number of males that responded. And then 10, number 10 here, describe the data to be counted in cell N. So I'm looking for cell N. Okay, there it is. And so I see it's on the margin, and I can see that N is going to just have the frequency of the total number of people who wanted to freeze time, both males and females together, the total number of respondents that wanted to freeze time. This is kind of how you kind of read this two-way frequency table, right? You're looking at the row and the column to determine, what goes in this box. Describe the data to be counted in cell R. Cell R is interesting because cell R is going to be the total number of males and females together. It's going to be R. R is also the total number of respondent superpowers together, right? If you add all these up together, you should find the same number as you would if you added all these up together, okay? That's R. R is going to be the total number of respondents, or the total number of surveys in the sample. Cell I. Cell I is the number of students who selected invisibility as their favorite superpower. Using this information, given in example 1, what is the value of this number? And do I still have it? I don't have it anymore. So if you were to go up to example 1, sorry. I wanted to show you where I got this. If you were to go up to example 1, you'll see here's all of our data, right? And what you could do is you could just highlight all this and do like a Control-C or copy all this so that you have it closer. And when I did it, I just put it into a comment over here, okay? So I can kind of refer to it. So back to that question. Cell I is the number of male respondents that selected invisibility as their superpower. Using the information given in example 1, what's the value of this number? Okay, so I'm looking for invisibility, and I see 75 students selected invisibility as their favorite power. 48 of those students were female. So I can go look for cell invisibility. I can say, okay, 48 females wanted invisibility as their superpower, and 75 total people responded. And again, I apologize, but assuming some kind of gender binary thing going on, you do take the 75, subtract 48, and you figure, well, whatever's left over from the 48 females are males, all right, in this assumption. So that's 27. 75 minus 48 is 27. That's how we got this 27 number in there. We kind of inferred that from our clues. We're detectives a little bit, all right? So, cell I is 27 males chose invisibility. And again, that's the 75 total, minus 48 females. That's how we found out there was 27. Number 13. Cell D is the number of females whose favorite superpower is super strength. Using the information cited in example 1, what is the value of this number? So here I have over in my comments the copy and paste from example 1, and I'm looking for super strength. There it is. Remember, that's the one where there's 26 students indicated super strength as their favorite power. 25 of those were male. All right. So 26 people said that was their favorite superpower. 25 of those were male, and making the unfortunate assumption of gender binary, that leaves one female student wanted super strength. Okay. That's how we found 1. And I don't have these on the notes, but I'll talk about them, all right? Complete the table below by completing a frequency count for each cell based on the summarized data, all right? So what you're going to do is you're going to complete this table based on the stuff from example 1, all those little clues. So let me help you out just to get started with. Let's do the fly. 100 students indicated that fly was their favorite power. So I want to put 100 students as my total under fly on my two-way frequency table. 49 of those students were female. So I put 49 under the females that wanted to fly. And then I do 100 minus 49 to find out what G is, right? I find out the remaining. And I keep going like that, right? I've already got invisibility there. What about, I already have superstring. What about telepathy? Okay, telepathy is 118 students total, 70 were female. So telepathy, what was it again? I already forgot. 118 total, 118 total. And then what was it? 70? 70 were female. Okay, 70 were female. So, 118 total wanted telepathy, and 70 were female. Then I could take 118, subtract 70, and the remaining we'll just assume are male. Okay, that's how that works. Now, once you've got an entire row completed, you can add up A, B, C, D, and E and find F, right? And hopefully all this will add up to the same number in the end. To find any of the marginal frequencies down here, if you didn't have them, you could just add the males and females together to find the total marginal frequency. What about fly? What do we have there? Oh yeah. That mean what? 51? 100 minus 48, 49? 51, right? I feel like that's right. Freeze time, right? 131 students wanted that. 131. All right, I'm getting that. 131 students selected the power to freeze time as his favorite power, and 71 of those were male. 71 of those respond for male. So what's 131 minus 70? All right, well, grab our math machine. When the math machine decides it wants to turn on, 131 minus 71. 60. All right, so 60 is what goes in here. You feeling that? You feeling that yet? Telepathy, okay? Let me bring the math machine over here. I've got 118, 118 total. I know 70 of those were female, so I subtract the female, and what's left over is, presumably to be male. And then, okay, now we have all of our data in the inside done, and we even have these done. To fill these in, we're going to have to add everything up, right? So let's do this. To find F here, I got to add A plus B plus C plus D plus E. So 49 plus 60 plus 48 plus 1 plus 70. Well, that equals 228. 228. And then for the next one, I'm going to add G plus H plus I plus J plus K. All right. This is a marginal frequency. So I got to add the total up, right? I got to add the total up. So 51 plus 71 plus 27 plus 25 plus 48 is 222. 222. You can barely see that. My apologies. Let's see. Let's go a little darker. I highlighted it. Oh well. No, wow, jeez. No, that's what I wanted, wasn't it? Oh, jeez. Okay. I'll get it eventually. Yeah, that's much better. We can actually see it now. Okay. And now that we have that, our last but not least, ours the only that we have missing. All we gotta do is add up either all of these or all of these, and they should add up to be the same number, right? If we did everything right, we should add up to be the same thing. So, okay, I think R is gonna be 450. Oh, that makes sense, right? We had 450 total respondents in the sample, but also if I add this marginal row, I should also get 450. Plus 75, plus 26, plus 118. Should be 140. Drum roll, please. Oh gosh, what did I goof up? Oh, you see what I goofed up? I put 18 instead of 118. So, I want that back. But this time I want to fix it. I'm going to make it 118. Drum roll, please. All right, 450. We did it. All right, we're there. So 450 goes in there. Okay. All right. So we completed the table. How many students chose telepathy as their superpower? Let's see. Telepathy. 118 students chose telepathy. Now, see how easy it is to find information when you have this table? What about percent? What percent of students chose telepathy as their superpower to the nearest tenth of a percent? Okay, here's how you do that, the percentages. I don't know if you remember how to do this, percentages. But actually, I want to actually go back and I want to read the question a little more carefully. Because if I have a question mark in my head, you probably I'm not explaining it slowly enough. All right, because I had a little question mark when I asked that. What percent of students chose telepathy as their superpower to the nearest tenth of a percent? And the reason why this is tricky is you have to read these very carefully. What percent of students chose telepathy as their superpower? All right. So what's the sample? What are we looking at? What's the part? Because percentages are always about parts of a whole. Well, the part is the students that chose telepathy. Okay, those that chose telepathy is the part. What's the whole? Of the students. Of the total students. How many chose telepathy? Okay, so this is our part, and this is our whole. Got it? Okay. So this is, now that we have this armed with this information, let's go back and look. Our part is the students that chose telepathy, 118. That's our part. We want to know, what is 118 out of what? Out of the whole. What's the whole? Of students. Of total students, right? And what's our total students? 450. So we do a little, make a little fraction here, right? We do a little division. We're going to say, what is 118? How many times is that, going to fit into, or actually, how many times is 450 going to fit into 118, right? We're trying to figure out a percentage. We're going to get a decimal out of 1 when we press enter here. Okay, this is a decimal out of 1. Do you remember how to convert a decimal out of 1 into a percent? All right, remember? Well, you want to remember percent. How many cents are there in a dollar? There's 100 cents in a dollar. So 100% is a whole dollar. 50% is 50 pennies, right? Or 50 cents. 25% is 25 cents out of a dollar. Okay, so we need to convert this percent. This is a decimal out of 1. We need to multiply it by 100. Multiply it by 100 to convert a decimal out of 1 to a percentage. If I wanted to convert a percentage into a decimal out of 1, I would divide by 100, because there are 100 cents in a dollar per cent. Okay, to see how I can just convert this over back and forth, no problem. So this is 26.2222222%. Well, it told us to round to the nearest tenth, right? So we look at the hundredths place. We see that the number there is a 2, which is less than 5. So this is round down. We just got 26.2%. All right, 26.2%. That's what you'll put in 16. 26.2%. Oh, okie dokie. Let's see. How many males were surveyed? Well, I go back up here. What was the total males? Well, the total males I'm going to find that in this marginal frequency column, 222. So on 17 there, we can say how many males were surveyed. You can write 222 right in there. And last but not least, what percent of females wanted invisibility as their superpower? Okay, let's read this very carefully. What percent of females wanted invisibility as their superpower to the nearest percent? Okay, so we're going to look for part and whole. Part and whole. What's the part? The part is the ones that wanted invisibility. And what's the whole? Of females is the whole. So the part is wanted invisibility. Of females is going to be our whole. You got that? Let's go back up and take a look. Okay. Our part are females that wanted invisibility. All right. Our part is females that wanted invisibility. That's 48 of them out of divided by fraction. 48 divided by, and what is our whole? Is of females, of total females, what percent of those females wanted invisibility? That's kind of like how you have to read these questions. Of females, of the total number of females, what percentage of those females wanted invisibility? So the whole is the total number of females because it's of females. This is the trickiest part is reading these questions, interpreting and analyzing them, okay? The easy part is throwing it in the calculator once you've got it interpreted. So 48 divided by 228. There we go. I get this number out of 1. I would like to convert this to a percentage, right? Remember, I'm going to multiply it by 100%, converting a decimal out of 1 into a percentage. I multiply by 100. I can turn it right back into a decimal I can use to multiply it by dividing by 100. Just like that. Right? Converting it back and forth. It's 21, and we're rounding the nearest tenth again. Okay, so I got to look at the 100th place to round to the nearest tenths. I'm looking at the 100th place, which is where that 5 is. And 5 is equal to 5 or greater, okay? Which means I need to round up, which means the 0 rounds up to a 1. So I get 21.1%, right? 21.1%. That's, oh wait, did it say to the nearest? Look at that. Tricky. I thought it was going to be 1/10 of a percent again, like it was for 16. No, in fact, 18 is the round to the nearest percent. You're just going to write a straight up 21% in there for 18. 21%. Okay, 30-minute video has gone by, and I've taken you through all the classwork. I think some of this homework is going to be kind of independent. We might walk you through some of it. We would like you to try some of this on your own. So you're going to be working with a two-way frequency table regarding gender and different kinds of sports, clubs, after-school activities, jazz band, jazz club, and intramural basketball. Okay. Let's see. That first question. Let's do a little survey of this. A survey asked the question, how tall are you to the nearest inch? A second question on this survey asked, what sports do you play? Indicate what type of data, numerical or categorical, would be collected from the first question. What type of data would be collected from the second question? All right. So, you tell me, how tall are you to the nearest inch? Is that categorical data or is that quantitative data? Okay. Is that numerical or qualitative? So think about that. And then what sports do you play? Is that categorical or is that quantitative? Is that a quality or is it a number? All right, and another random sample of 100 surveys were selected. Jill had a copy of the frequency table that summarized these 100 surveys. Unfortunately, she spilled part of her lunch on that copy. Oh no. The following summaries are still readable. So we have an incomplete frequency table. You are going to help Jill recreate this table by determining the frequencies in cells E, C, E, J, and Q? Oh my gosh, how do we get a Q? I don't know. Well, anyway, there it is. So you're going to fill in these. How would you do this? Well, C is going to be easy, right? You're going to take the total, subtract the males, and you'll get the result. The remaining number is going to be females, right? Let's see. This one won't be too hard because we have one variable, right? So we have a total number of 9. 5 of those were female. So 9 minus 5, that goes right into J, right? Take your total, subtract the number you know to find the number you don't. Now notice here, we have 2 variables. We have 2 unknowns, which means we're going to need to solve this a different way. Well, now we have almost everything on this row except for E. We could figure out E by taking 55 and subtracting, the 5, whatever goes in C, subtract the 15, subtract the 12. Whatever remains is E. Same thing with Q over here. Take the 100 total and subtract 9, subtract 25, subtract 31, subtract 24, and you'll have the remaining telepathy there. Okay? Of these cells, which represent joint frequencies? Remember, joint frequencies are the ones that join 2 pieces of categorical data. So all of this are joint frequencies, right? All of this and this are marginal frequencies on the margin. All right. And I think I'm going to let you try to puzzle some more of this out with what you have here. Okay. I think that's pretty good. I don't want to do it all. I want to give you a chance to have some independent practice here. So hope these videos are useful to you. Remember, you can slow me down, pause me, all that kind of good stuff. I won't take offense. That's cool. I'll be happy that you're getting the most